Thank you so much. So, my name is Michael Rosenberg. I work at Cloudflare, and today I'm going to present web application transparency along with my colleague, Dennis Jackson from Mozilla. So, starting with motivation, I really want to run Signal in my browser. I really want to be able to go to chat.signal.org and specifically get JavaScript code from the server and do some encryption on my end, and then send some message to the server, and then have that message get sent down to the recipient. And one important property about Signal is that it has to be secure even in the face of a malicious server. If the server decides to act completely maliciously, my messages have to still be encrypted. Unfortunately, this setup makes that impossible. If the server is malicious, it can just serve me malicious JavaScript, and then whatever thing I do for encryption is up to the server. So for example, the server can just send me JavaScript code that exfiltrates all of my messages. Now, this is actually a general problem. It's not just for Signal, obviously. Thomas Tacek wrote about this in 2011, and this has been a problem on the internet since the beginning of the internet. It wasn't made for this. So there are plenty of things that you can't do in your web browser securely. You can't do confidential compute in your browser. You can't have a password manager in your browser. You can't vote in your browser. And you can't have a cryptocurrency wallet in your browser. So to get intuition for why, for how to fix this, we'll look at an ecosystem where this is not a problem. So if I have the iOS app for Signal, I don't have the same issue. Why is that? So I get my iOS app from the App Store, which is a third-party distributor. This is the party that's trusted to give out copies of the binary to individual users. This gives us three properties very roughly. Integrity, which is it is difficult to maul the apps once they are sent by the App Store. Consistency, which is to say that every user gets the same app, roughly. And transparency, which is that app versions that are published by the App Store are visible at the very least to the developer themselves. And some app stores do this to an extent and some don't, but this is roughly a property that exists. Unfortunately, app stores have downsides, mainly that they're extremely centralizing. App stores wield an immense amount of power, arguably more power than any single party should have. So we would like to get some of these features for the open web without centralizing in a single app store. And to be more specific, we have some desiderata for any kind of scheme that we'd like to make. So first off, we want this to be strictly opt-in. We don't want anyone to suffer from any kind of deployment if they don't want to participate. Security should be free for end users. So a browser should not have to pay in latency cost if they want to use this feature. So there should be no extra network round trips. Similarly, browsers, in the same spirit of being free, at least performance-wise, we don't want users, end users, so browsers, to spend any extra storage space on a per-site basis. We also don't want users to have to exchange transparency for privacy, so we don't want any extra fingerprinting vectors to be introduced. In addition, we want this to be an open ecosystem. We don't want people to have to pay for the core service. We want an easy on-ramp, an easy off-ramp, and we want this to be as exposed as possible to the browser APIs so that people can build plugins and build on top of transparency and benefit from all of these security guarantees. So in this talk, we will talk about a constellation of specifications known as Web Application Integrity, Consistency, and Transparency, or WACT. This is very early work, and it's work between browser vendors, cloud service providers, and encrypted communication providers. we'll split this talk into 4 parts. So first, we'll talk about the web application itself, defining what we mean by integrity. Then we'll talk about the transparency service. We'll talk about how this looks on the client. And finally, protocol extensions. So first, what do we mean by web application? So the end goal, spoiler, is to put things in a log. So for an Android app, this is easy. You just have APK files, and you stick them in a transparency log. You can't do this with web applications. Web applications are much more diffuse than a single APK file, right? It is a set of pages, and each page might have different assets that it loads. And these assets can be loaded either from external servers or locally on the server. And in addition, pages can link to each other, and each of which might have their own set of assets. So this is very far from a single APK file. So our first step would be to constrain and fully define the entire web application in one thing. So we can do this in 2 steps. First, we can constrain each page alone using sub-resource integrity, which is an existing web standard, which basically says every time you load an asset, you specify the hash of that asset. And when you receive that asset, you compute the hash, and if it doesn't match, you reject, meaning different things in different scenarios. And so this essentially constrains each individual page to be well-defined with respect to the assets that it loads. The pages can't do anything anymore outside of exactly what the code says. However, pages still link to each other, and you can't have an integrity manifest on a hyperlink. So there's still some malleability here. So the second thing you could do is have an integrity manifest, which is defined in one of the WACT specs. And this is essentially a file that contains the hashes of, for example, all the HTML files under a path for a single site. And this is the final step. This narrowly constrains all of the pages together into a single thing. And so this single manifest is going to be the thing that defines what a web application is. So all of the operations that we do for transparency are going to be operating over this manifest or a hash thereof. So now we can talk about what the transparency service does. So the transparency service is a service that manages the main data structure of our transparency scheme, which, surprise, is a tree. Specifically, it is a prefix tree, aka a trie, which is a tree whose leaves are indexed by strings and are sorted by prefix. Each leaf has a hash chain of the manifests that have historically belonged to the website. And this hash chain is an append-only data structure. Some people use Merkle trees in this scenario, but hash chain also happens to work. And finally, there's a witness, which we won't describe in too much detail, but basically the witness does the thing you'd expect. It ingests a stream of events from this transparency service and updates its own copy of the prefix tree and reconstructs the root hash. And if it agrees on the root hash, it'll cosign the head. Finally, since manifests grow quadratically with time, assuming a constant rate in the number of sites that are enrolled in transparency, we can't store manifests forever. We have to have some sort of eviction policy for these things. So just imagine some cutoff on the transparency service. So we obviously need a monitoring story. So what does this look like? It happens to be very efficient. So if a user wants to monitor their own site that they've enrolled in transparency, they simply ask for a site, and they get the inclusion proof of their site in the prefix tree. And all they have to do is check 2 things. Check that the manifest hash is unchanged from the last time they requested this proof, and also check that the time created of this leaf is unchanged, which is to say it hasn't been unenrolled and re-enrolled, because that would have given it a new timestamp. This is significantly more efficient than the process of tailing a log. I'll describe this quickly. So in the certificate transparency case, as we know, tailing a log can be quite expensive for bandwidth. So if you only have a gigabit per second of bandwidth, you can support about a few thousand monitors. So in particular, this means that you can't self-monitor not everybody can self-monitor their CT, their certificates. They have to rely on a monitoring service. On the other hand, if you have a log with structure, you can query the log and get back the latest value and know for a fact that nothing has changed since the last time, so you don't have to do the same tailing process. Borrowing an analogy from Brendan McMillan, this is the difference between reading through an entire stack of papers versus using a filing cabinet. So with the same amount of bandwidth, this can support about 2 billion monitors, which means that people can actually self-monitor with this. So finally, one of the main properties that we need to ensure for a transparency service is that it is not too centralized. So we want to avoid this any kind of lock-in property that would happen. And so currently, if we have a single transparency service, this means we have a single point of trust and a single point of failure, which is a problem. So a natural solution is to permit many transparency services. And we have to be careful here, because if we permit 1 million transparency services, then we have an auditability problem. Yes, maybe we have transparency, but there's no way to even check what is happening anymore, because if there's 1 million users and 1 million different manifests, then how can anyone make any guarantees about what's happening on the website? So the property that we kind of want is consistency, which is everybody gets the same version of the site. Now, we can't actually achieve that because consistency is a very strong property, and we can't guarantee that everybody gets exactly the same version, but we can weaken it a bit and say roughly everybody gets the same version. So how do we weaken that specifically? Well, we allow transparency services to serve different copies of the manifest. So if depending on the transparency service, you might get a different copy of the manifest, and also there might be multiple manifests that are valid at a given time. So you can get, a few manifests possibly into the past that are still valid. So instead of 1 million, you have a handful of manifests that could be in play at any given time, and this is far more reasonable. So that was the server side, but to talk about the client side, I'll give it to Dennis.
Thank you, Michael. Thanks, Michael. So, yeah, the client-side perspective on this is challenging. So obviously, some websites are going to want this stronger security model, but not all of them. So the first question is, how do clients know, how do browsers know which websites have been enrolled in transparency and that want this stronger security property? If they've been enrolled, how do they know that the website is presenting a transparent set of an application manifest? And when things go wrong, how does the client respond? What happens next? What's the recovery story for both websites and for users? So telling clients about enrollment, the sort of obvious solution is, just have the browsers, they're connected to the internet, have them talk to the transparency service and ask, is this website using this strong transparency property? And this has real issues. You typically can't assume that browsers can talk to a third party. You can really only assume they're talking to the website they're actually connected to. It would be horrible for privacy because you'd be revealing to that transparency service which website you were interacting with, and you'd be adding latency in the form of round trips. So this is a bit of a non-starter. But what we can do is have sites tell users that they're enrolled in a kind of trust on first use model. So think HSTS, if you're familiar with that. The site is just going to tell the website, so the site is going to tell the user, I'm enrolled in transparency, hold on to this, remember this. And this works, but we have users that run in private browsing mode and that might want to do confidential things on a site in private browsing mode. And in private browsing mode, we can't store state. We can't store state about the fact that a site's been enrolled. And worse, sites know when a user's in private browsing mode. So this would be a particularly convenient way to attack users that are definitively not doing transparency. So what we can do instead is we can give all the browsers that we distribute a big list of all the sites that are using transparency. And this is similar to HSTS preload. And the problem with this is really list management. We, as the browser, have to basically manage this huge list of who's enrolled and who wants to be enrolled and who wants to be unenrolled. It's time consuming, it's difficult, and we don't love it. but actually we don't know of a better way. So if already you think you see a better way to achieve this kind of downgrade resilience, we would certainly love to hear about it. So once the browser knows that it has to enforce transparency for a particular site, the story is then relatively straightforward. The site's going to have to present this manifest that Michael described, an inclusion proof, proving that that manifest is in a transparency service, and then a bunch of signatures from the transparency service from some witnesses to show that it's been logged correctly and that it's been supported. But each one of these steps is a different place where something could go wrong. The manifest might not be passable, the inclusion proof might be wrong, the signatures might not validate, or they might be from witnesses or a transparency service that the client simply doesn't trust. And what are we going to do when things go wrong? Well, we're going to show them an error page. And if you've used a web browser, you've obviously been infuriated at some point when a site you've needed to access simply hasn't worked. And this is a real problem because obviously the story we'd like to tell people when they see an error page is very, very bad things are happening. Stop what you're doing. We're doing a great job protecting you here. But in practice, something's gone wrong. There's been a bug. There's been a misconfiguration. An intern's been let loose on prod. And, really this error page, from the user's perspective, these two situations are indistinguishable. And certainly the second scenario just seems much more likely. So if we tell users we're adding more error pages to the browser, they're not going to be happy. And I think website operators are also going to be pretty unhappy with that outcome as well, because it's risky to enroll your site in a new security service that might bring your site down for your users. So what can we do here? We've got this kind of enrollment signal. We've got this list that we have to manage that we may not be able to manage especially dynamically. What are we going to do when it all goes wrong? So we've got some faulty proof being presented. We've got an unhappy browser that won't load that site. We're going to give people an escape hatch. We're going to give specifically website operators a way to bail out of this system. And that looks like a special kind of tombstone value, a sentinel value, that is logged transparently. So that when clients are shown a tombstone value that traces up to a valid log, they just treat that as unenrollment. They no longer enforce transparency for that site. It's over. It's done. And from that client's perspective, carrying on, they don't benefit from the security of this system. But the fact that a website has issued this unenrollment signal is itself transparent. So monitors and third parties can see that a site has chosen, something's broken, and they've decided to unenroll. And this really sort of brings us onto the wider ecosystem, which is that client enforcement is important for any transparent system, but it's not the end of the story. So if, for example, you had a service, say Signal was enrolled in this, and that the Signal issued a tombstone value and an enrollment every week, the system would have no value. And this is like primarily a social problem that can actually only be addressed through policy and culture. Like similar problems are very much like if you've got a given list of manifests for a given website, do those manifests correspond to good code or bad code? Not addressed within the scope of this system. Now, there are things that you can do to solve that, the techniques from binary transparency like reproducible builds, scanning for malware, etc., but they're very much going to be on the basis of an individual operator. So we're going to provide a primitive here. It's going to provide a security system, but what people make of it is actually going to be more down to the website and the operator and a cultural expectation as it is about anything else. And I think this is true of most transparency systems. So we sort of talked through the client side there, and now we're going to look at the extensions very quickly. So we could certainly imagine that this threat model might not be right for you. In particular, we're going to sort of focus on making sure that this remains available, but you might want stronger security. You might want cooldowns on specific changes. You might want stronger code signing properties. And we see a way to extend this through the existing kind of browser extensions platform, where they can mediate this and impose stronger requirements, for example, if they'd like to. Similarly, applications might not be the only thing that you want transparency for. So there's a whole family of privacy-enhancing technologies making their way onto the web. So some examples are the things from Privacy Pass, like private access tokens and private state tokens, or IP protection systems like VPNs, private relay, mask. These technologies rely on a shared configuration file, and users only get privacy if they all have the same file, and transparency can be an important way to provide that. You also, might be updating your clients remotely with a log list, and maybe you'd like some transparency for your system, your changes to your transparency enforcement. This work is still at a very early stage, as Michael stressed at the beginning. There is a general explainer of the overall system that's available on GitHub that sort of talks about these different components and how they fit together. And more specifically, there's a transparency draft, which is sort of actively being developed. There's no running code yet. There's just a bunch of prototypes. And we would really love the community's feedback, especially on this aspect. So issues, PRs, suggestions, doom, optimism, it's all welcome. Thank you.
You mentioned that one of the problems you have is figuring how the website can opt in to this transparency feature. Have you considered that, well, at some point, somebody will most likely resolve a domain name to an IP address so they can connect? And maybe you can also provide that kind of hints on the DNS so they are secured using DNSSEC.
Yeah, that's a really interesting idea. The main concern with DNSSEC is that its deployment is fairly uneven. So a substantial fraction of sites don't have access to it because of particular issues with their higher level domain registries. Another issue is that clients have typically been reluctant to enforce DNSSEC because misconfiguration breaks sites. So in the situation where you receive a DNS record and it doesn't verify, clients typically tend to trust it anyway. So I think it's the kind of thing that we could use as an adjunct, but I don't know that it's the kind of thing that we could rely on exclusively. But yeah, it's an interesting suggestion. Thank you.
Hi, thank you for the talk. In the beginning, in the slides where he had showed like statically generated pages like index or about us or anything like that, that's typical of basic static pages. What are the thoughts around dynamically generated pages of various websites outside of just the fact that assets on pages changes every day, if not several times a day, depending on the development cycle where you are at. So I'm just kind of wondering what was the thinking around dynamically generated pages and how to check the integrity on that.
Yeah, yeah. I mean, this is a tough thing that we don't have an answer for. If a page is dynamically generated, then it's really hard to make any claim about what the hash is going to look like. Theoretically, you could issue a manifest every time it changes, but often dynamic pages change also based on every user. So it's not so much for that. This is definitely an interesting problem that we see for maybe future versions, but for now, it's something like, I have a progressive web app that has a really small set of HTML, CSS, and JavaScript stuff. Like I'm self-hosting CryptPad, for example, right? Like how do I get any amount of transparency or code signing on something like that? So yeah, the scope is more narrow than that, and that's an unsolved problem.
I would say that some web developers are willing to go the extra mile to try and make that work within their system. So Meta, for example, have a code verify extension, which effectively tries to do a similar thing to what's being described here for integrity. And obviously, at the scale of Facebook.com or Messenger, that's a incredibly complex operation. But they've been willing to invest the time and energy to make it work. So I think there's reason for optimism.
Any more questions? We have plenty of time. We are running ahead.
Hi, thank you. Who runs the logs in this system?
It's effectively, if you like, a root program model, in the sense that anybody can come up. We envision that anybody can come along and say, hey, I'm willing to stand up a transparency service, and with a certain amount of impetus, we can, check that they're doing that correctly and then trust them to do it. In the beginning, seeding these things is always hard. When you sort of go back to the early days of the web PKI, there were certainly some interesting deployment models for how CAs operated. We could certainly imagine bootstrapping this to make it work, but I think we'd have no interest in running it super long term. We would ideally want to hand this over to interested parties.
Thanks very much for the talk. I'm curious to hear more about the eviction policy that you mentioned for the manifests. Do you have thoughts on, is this something that's time-bound or based on the amount of manifests? I guess I'm curious if there's some opportunity where someone could maliciously generate enough manifests for a site that you end up evicting something and hiding some content from a verifier.
Yeah, that's a very good point. We don't have any specific eviction policy in mind right now. Just a note that one has to exist. Otherwise, you just get infinite storage. Actually, I encourage you to make that as an issue on the GitHub.
If you're using an extension to monitor more of the transparency, it seems like you're putting a lot of trust in that extension. And like, is Mozilla planning to have like transparency for extensions? That's maybe the next question.
Yeah, I think transparency for extensions is a really interesting area.
Amazing. Well, let's say thank you to Dennis and Michael again.